Hello and very good evening to our lecturers, Roger. Today we will present about our group project for ITT 270, which is the Arduino project, and the title is Automatic Clothesline System. First of all, I would like to introduce our group members. Firstly, we have Roslian Shah bin Rostan, which is me, and then we have Muhammad Khairi Adam bin Ibrahim, and we have Syed Shafi'i Aiman bin Habib Ishaq, and lastly we have Muhammad Danish Rahimi bin Sudirman. To begin with, this project focused on developing an automatic clothesline system using Arduino designed to address a common household challenge protecting clothes from unexpected rain. Sudden weather changes can make it difficult to keep laundry dry, especially in regions with unpredictable climates. By integrating rain sensor, ultrasonic sensor HCSR04, and motorized mechanism, the system detects environmental conditions in real time and responds accordingly. When rain or strong wind are detected, the clothesline automatically retracts to a sheltered area, preventing clothes from getting wet or damaged. This innovative solution enhances convenience and reliability, reducing the need for manual intervention while ensuring that laundry remains protected regardless of changing weather conditions. Through the combination of hardware and software components, the system offers a smart and efficient approach to household laundry management, making it particularly useful for individuals with busy schedules or limited mobility.
And for our objective, first we want to create an automated system that can recognize rain, strong wind, and instantly relocate the clothesline to a protected spot under the cover. And the second objective, we want to improve household convenience by doing away with the necessity for physical intervention during abrupt weather skills. So you don't need to do anything, and the system will do it for you. And lastly, to use accessible and affordable technology to promote effective and user-friendly home automation, making it feasible for wider use. Everyone.
Now for the techniques used in this system, the automatic clothesline system integrates hardware and software for efficient operation. It uses an Arduino Uno as the control unit along with a rain sensor, ultrasonic sensors, and a servo motor with a driver and a rail system. The sensor monitor environment conditions, detecting rain and wind. When triggered, the Arduino activates the motor to retract the clothesline to a sheltered area. Once conditions stabilize, the system resets. The software written in C++ processes sensor data accurately, prevents false triggers, and ensures stable operation. Extensive testing confirms the system reliability for real-world use. I will be explaining the coding for the ITT project for our assignment. Here is the library, the wire hedge, the liquid crystal, A to C hedge, and servo. This library is used for display and the servo connections. Next is the trigger pin to the two ultrasonic sensor trigger pin and echo pin connection definition, and servo, and also the raindrop sensor analog pin. Next is the liquid crystal I2C LCD definition, and it uses the 0 times 27 address and has 16 columns and 2 rows. Next is the definition of the float of distance threshold, wind speed threshold, raindrop threshold, hold time, and also the last activated time, and is a servo active. This constant definitions and also the long and bool will be used in the code later on. Here is the setup code for the Arduino project. The LCD begins and the turning on of the backlight. the pin mode for the ultrasonic sensors and rain drop sensors, and also attaching the servo to the servo pin. And we also have the wind speed for LCD. Okay, here is the main loop for the our Arduino project. First, it will define the duration and the distance for sensor A and sensor B. Then for sensor A, it will set the trigger pin to 2 microseconds. Then it will set it to high for 10 microseconds, and then set it to low again. After that, it will multiply it by the speed of sound, and then divide it by 2 to get the distance. Then the next block of code is just the same as the top one, but for ultrasonic sensor B. Then it will get the distance change by dividing distance B with distance A. Next, it will define wind speed, and it will go to an if statement and will get the absolute value of distance change. If the absolute value of distance change is bigger than distance threshold, which is 5, the wind speed will equal to absolute value of distance change 5 times 10. Then it will output the to the LCD the speed and wind speed. Okay, here this is the second part of the main of the Arduino project. This block of code checks if the random value is below the threshold or the wind speed exceeds the threshold. If the servo is not active, it will move the servo from 90 degrees to 0 degrees and updates the last activated time. If the servo is active and the hold time has elapsed, it moves the servo back from 0 degrees to 90 degrees and set the active state to false. And then lastly, it will delay the code for 100 milliseconds. And that is the end of the Arduino code. And here is the schematic diagram for our project. All of the ground and 5 volt is connected to the breadboard, and how it uses the digital pin and the analog frame pin from the Arduino Uno.
For the conclusion, the automatic clothesline system successfully met its objective by providing an efficient solution for detecting rain and strong wind, and also automatically relocating the clothesline to a protected area. The system effectively eliminates the need for manual intervention during sudden weather change, enhancing household convenience. Additionally, the use of accessible and affordable technology ensure that the system remains practical, cost-effective, and suitable for widespread adoption in home automation. All from us at the end of the video presentation. This is our video for the demonstration of our project.
I'm walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town,